soccer slash football?
Well, I'm sitting next to Jose, so I do now.
I see. Are you guys in the lab or where?
We're in the library in one of the rooms that you can just close off and talk without disturbing a bunch of other people.
I see. Do they have good computers there?
Not in the area that we're at. It's across the way. We just are on our laptop and phone right now.
I see.
Yeah, there's a computer here that we're like a big TV here that we're thinking about putting a cord in and like putting it on the big screen though. So that's kind of fun. Oh, they're
Well,
poking
you
at wires.
should. You
Yeah.
should. Then you can watch it and listen to class too.
Yes, exactly.
I think that Amer's kids or grandkids are into soccer, football, but Amer, I don't think is so much. Is that true, Amer?
Yes, I left one of my grandkids. He's 4 years old.
And he's already playing soccer?
Yes. Trying to be rich and famous.
Well, he'll make more money than an engineer will.
Of course. Hello,
Dr. Mawali.
Chad. Hello, Chad.
Yes, Professor.
How is your ROM? Read-only memory.
How is my room?
ROM, read-only memory.
How is it? It's
Yes.
It's good.
Okay, running?
Not quite.
Why? Show me what you have.
I don't have it on my laptop. It's on my desktop at home.
Okay. Jose? Hello, Jose.
Jose is going to the bathroom right now.
Okay.
He'll be back in a couple minutes.
So you are available then. How is your program? Read-only memory.
My program, I'm on my phone right now, and so I do not have my computer.
No, is it working? Do you have any
yes,
problem with it?
Yes, it's doing good.
Okay.
Dr. McWally?
Bernard, you told me that you have it running, correct? Bernard?
Yes, Professor. Good morning.
Is it running good?
It's running good.
Okay. So it seems...
Professor Mbaye.
Yes, sir. Your question. Any questions? Okay. I'll proceed to our next target. It is random access memory, RAM. We are done with the read-only memory. And this random access memory, I can read and write. It is not read-only, it is RAM, so it can do read and write. This is the simple structure of RAM. Of course, we saw many complicated structures before, but this is a very simple. The data in it is 32-bit. And the write or read address, it is 12. So 2 to the power 12, I have 4,096 memory location, and each memory location, the width is 32-bit. 32-bit for data in, 32-bit for data out. Here in this system, I have here this is my clock, and this is my data that is coming in, and here is the right address. When I start by write enable, this is my write enable, I have here this data, and this is my address. It will be written. So this is the first one, first address, it will have this data. What about this address and this data? I don't have write enable here. So here, there is nothing written on this address. Or if there is something from previous runs, it will be there. But this data will not go to this address because I have here the write enable is not working.
Professor,
Yes.
quick question.
Yes.
So it says W adder. I thought that was the right address.
Right
Where's-
address. Yes, yes. I'm writing to the memory location.
But the data in is that the actual address, and the W adder is a location for that address.
Data in, this is the values that will be stored. Right address, that is where it will be stored.
Okay, perfect. Thank you.
Write enable is to start writing. So in the second clock cycle, I don't have write enable. So the data that is 5, 6, 7, 8, it wasn't written anywhere. So the address 768 X means hexadecimal.
Gotcha.
Now it has whatever it was there before.
I see.
Then I have a new address, a new data, and I have write enabled. So this data will be written. A new address, new data, this data will be written. Here I don't have write enabled, nothing. So out of this cycle, I have what? I have this information, 1, 2, 3, 4, written in 13B. 9 ABC written in 49A. 7654 written in B32. Now, if I go to a reading cycle, at this point, I want to read what is stored in 1.3b. 1.3b, this is 1.3b. What do we have in 1.3b? It is 1, 2, 3, 4. Here I got it. It took one clock cycle to appear. Now I want to see whatever is in 49A. Where is 49A? It has 9ABC. Here it is. Now I want to see what is written in 768. This is 768. But when we started writing to it, the write enable wasn't there. So I will get whatever was there earlier. I don't know it. But it will never be 5, 6, 7, 8 unless it is luck. Okay? Any questions? Any questions? Now let's see the RAM in VHDL. Clock, address, write enable, data in, and data out. And data in and data out, here I have them 8-bit. And the address, it is 4-bit only. Here I will start my architecture. Here we said, as we did in the ROM, I'll define a new data type. This new type, I will call it RAM underscore type. What is it? It is an array. The array has 16 addresses, 0 to 15, 16 memory location, and each memory location, it will have 8 bits, 16 memory locations, and each one will be, can store 8 bits, 1 byte. Then I have my signal as RAM, and its type, it is RAM type. As you can see here, I selected it to be a signal. Why? Because it can take data in and data out. So I had to have it as a signal. Now I go to my process, clock, begin. If rising edge, and if I have write enabled, DIN, whatever is on DIN will go to the RAM, but go to which address? The address that you have it on your waveform generator as the address you had it in your ROM, the address here will be converted into integer, so the RAM will know where to put it. So DN will go to this address. This is the end if. If we have write permission, we start getting the data in, out. And if we don't have the write permission, well, we are getting the data out. Data out, whatever on the RAM, and this is the address, I will get it out. This is my end of behavioral. We need to try this one now. Do you have any questions before I let you start working on it? Any questions? Okay, very good. Please feel free to share the screen and ask your colleagues.
Professor, I actually do have a question.
Okay.
On the address on the example waveform you gave, you had like A's, B's in it. How do we show that in binary for the input on our code? In the previous slide, you gave the, yeah.
Here, I have here 12-bit address. 12-bit address.
Because on the like the
Just a
actual
moment, please. Just a moment, please. And for this 12-bit address, and this is the data in. Can you see data in? It is 32-bit. And it is very, very hard to show 32 lines. That is why it is easier to move to hexadecimal.
okay,
So
we're still using numbers.
Hexadecimal, each digit here, it has 4 bits. Each digit, it is 4 bits. So writing it in hexadecimal, it is much easier. 4 times 4, this is 32-bit, and 16, and here 3 times 4, it is 12. So in our example here, my address is just 4 bits. So you can use it the same as you did with the ROM. because it is very limited.
Okay, thank you.
You don't have to go to hexadecimal. Okay, thank you. Cameron Castillo,
Yes, Professor.
would you please check your mail? Email?
Email? Yes, I can.
Thank you.
Did you send me something? Because I didn't get anything.
Send it by email.
Yes, I checked it. I didn't see anything.
Okay, you got it now?
Let me double check again. Are you sending it to Cameron dot the OIT? Cameron dot Castillo at OIT?
Yeah.
I'm not seeing anything. I don't know what's going on there.
Okay, let me do it again.
Yeah, I'll put my email in the chat real quick.
Okay. No, I sent it to Gmail, but I sent it now to your OIT account.
Okay, I'll check both of them. They should go to the same thing. I have them forwarded to each other, so I don't know what the deal is there.
Hello, Vitaly.
Hello,
Vitaly,
Professor. Yes, sorry.
how's it going?
Good. But I'm currently at school. So I'm not on my desktop to run the program, so I can't show you my waveform.
Okay.
But I was also able to fix my ROM yesterday. I got much better results.
Okay, great.
There's one thing. For some reason, that first data set
Yeah.
still is showing up in the data out,
Mm.
even before it's triggered by the clock. But just that one. Every other one is perfectly triggered. So I don't know. Maybe it's in the waveform settings, but everything else worked great. So I can show that to you on Friday if you need.
Please remember on Friday we have our quiz.
That's right. Okay.
Our quiz is on Friday. We have quiz on this Friday and the next Friday. And please note that we have limited time. It is not open forever. After the time is up, you will never be able to upload your work. So please try to finish within the time limit.
You said the quiz is going to be like our previous ones, right?
Similar to them, yes.
Awesome. Thank you.
Okay. Hello, Samuel. Samuel,
Yes, hello, Professor.
how is it going? The RAM.
I'm sorry, say that
The
again.
random access memory. Are you working on it?
Yeah, I'm working through it.
Okay, okay. And do you have any other assignments that are due?
I'm going to turn in lab 3 here soon. I've been kind of behind.
Okay, great. Thank you, sir. Okay,
Thank you.
we are gonna end our lecture now. And please remember, we have a quiz on this Wednesday, this Friday. And I wish you the best and see you Monday. Bye now.
Professor, quick
Yes,
question.
sir. Yeah.
On the quiz, what material is gonna be on it?
It is gonna be similar to the other two quizzes. Okay?
All right, Professor.
Good luck.
Have a-
Bye-bye. Bye all.
And